When we began this course, I quoted the German engineer Anton Tedesko, who stressed 3 important points on which depends the success of vaults. Quote 1, designers learn from having experience with full-scale structures. 2, engineers should visualize the actual construction during the design stage. The economy of shells depends on the close collaboration of designer and builder. And 3, even in working with prestigious architects, the engineer must stand firm, making it clear as to what can be done and what should not be done. We would like to rephrase Tedesko as follows.
The success of a vaulted design depends on the strong collaboration between engineer and architect early in the project. 2, it depends on the proper form. And 3, it depends on economical construction methods.
Hans Schober, the leading engineer for Schleich Bergermann & Partner for the Berlin Central Station, had this to say about collaborations with architects. When we work together, it is often the case that the architect has ideas about the structure different than those of the engineer, and it stimulates the engineer to innovate. In turn, when the architect takes input and learns from the collaboration about good structural ideas, the architect is also stimulated by the engineer. If you don't exploit this potential, you miss a lot of new ideas and opportunities. It is very important that both disciplines work together from the very beginning.
The architect Jürgen Hilmer of the architectural firm GMP, who led the Berlin Central Station project, concurs. The most significant aspect of a successful collaboration between architects and engineers is not who assumes the leading role in regards to formal and aesthetic decisions, but rather the congruence not only in the approach to the design, but also in the fundamentals of design work. Good design is dependent on a give-and-take basis.
One can argue that for designing a bridge, such intimate collaboration is less significant. But for enclosed spaces, such as vaults and other buildings, where both the spaces and forces need to be carefully considered, collaboration between both disciplines early on in the project is crucial. This sentiment is expressed by other structural artists of building forms as well. The success of a vaulted design also depends on proper form.
Now that we have access to geometric digital modeling tools, more architects base their work on aesthetic considerations to achieve visually expressive forms. These sculptural designs can be valued for their inventiveness of plastic forms and aesthetics, but not always for their consideration of structural behavior. This particular design approach often lacks structural efficiency and thus uses a significant amount of material. These sculptural designs often lead to unfavorable internal forces and develop bending moments, which we have learned is the least efficient means of carrying loads in vaults.
This tension between sculptural designs and structural efficiency is not new. In an essay reflecting upon the work of Pier Luigi Nervi, Candela writes, quote, "The extraordinary success of Nervi's work has decisively influenced this unjustified breakout of structuralism, since the architects, eager for glory, think they can find the presumed imitation of the Italian master in an easy formula that will quickly lead them to immortality. The result has been a series of pseudo-structural forms totally deprived of logic and sense of equilibrium." That was Félix Candela in 1964, and it was pretty harsh, I would say. And while Candela implies that these pseudo-structural forms, which we are calling sculptural designs, should not be built ever, Nervi allows for exceptions for temporary structures. Sigrid, why don't you tell us what Nervi said in a book that he published in 1965?
Structural architecture of today, like that of the past and always, must give the impression of a stable and tranquil equilibrium, rather than that of an astonishing, if not frightening marvel of acrobatic exercise. Daredevil construction acrobatics, encouraged and made possible by present-day materials and calculating methods, at best must be limited to temporary structures with precise publicity goals such as exhibitions.
The success of a vaulted design also depends on economical construction methods. Never design anything unless you have at least one idea of how to build it is a motto taught to us by one of the best designers of today, Bill Baker. This motto applies to all structures, bridges, buildings, and vaults. For this course on vaulted forms, we saw how conscious the designers were about construction. For example, Tedesko and Isler repeated the formwork as much as possible. Candela found economy in shell building by using straight wooden forms that could be reused to create the doubly curved surface of a hyperbolic paraboloid. And Nervi innovated with a new material, ferrocement, and precasting to find economy in his works. Today, engineers have opportunities to be pioneers. We have new materials, new tools, and new forms. But we must have the courage to be a pioneer. Remember, creativity takes courage. With the proper training and discipline, engineers can play with their new tools and materials, as well as old tools and old materials, to arrive at vaulted forms that are efficient, economical, and elegant. And that is how you arrive at the art of structural engineering, through play that is bound by, but not restrained by, discipline. Thank you, Sigrid, for sharing this lecture with me.
It's been my pleasure.
And I hope you have enjoyed learning about vaults and the art of structural engineering. Thank you for watching.